I think what we've had for the past week or so has taken global warming and put it in the trash bin where it belongs. Now, I be honest, it just a week of really cold weather does not disprove global warming any more so than a week of really hot weather in the summertime proves global warming. But that's a totally different issue. Global warming is, there's a lot more behind that whole thing than they would like us to believe. So today we're gonna move onward. It feels like, as Larry said, it's been forever and a day since we were here last, and we're going to be going on to my second lesson on science in the Bible, and specifically science and creation, with the mindset of, are they as incompatible as we have been told? As we already had looked at in the first section, how there's so many scientific truths that we see in the Bible, and we're really dealing with a topic that is incredibly complex, because we're looking at what's the origin of the universe? What's the origin of everything that exists? Where did it come from? And that field is called cosmogony. Whenever you see ology, like cosmology, that would be the study of, that's the ology part, the cosmos, the universe. Whenever you see ogony, O-G-O-N-Y, you're looking at origins. That's a study of the origins of something, which I always get a chuckle when kids say, oh, well, you study meteorology, so you studied like meteors, right? No, not exactly. Close, but not quite. So we're looking at the origins of the cosmos, the origins of the universe. And it is one of the oldest scientific disciplines. The reason for that is we've always wondered where we came from. Where has the universe come from? Where did we come from? Why do we exist? All of that sort of wrapped together. It really and truly is one of the oldest disciplines that we've ever talked about. So what is the universe anyway? If we're looking at origins, if we want to talk about origins, what exactly is the universe? It's everything. It's everything that exists. That is the definition of the universe. Everything that we observe, every single thing that we see is defined as part of the universe. That's what it is. By definition, every physical law that occurs, the law of gravitation, Newton's laws of motion, all those things have to be obeyed in all places at all times. When we get situations where they're not, that's magic, or what we would define as magic. When we think of something being, that I can make something appear out of nowhere, well, there's no physical law that defines that. There's no physical law that describes how that could possibly be. So it's either got to be supernatural, something outside of nature, or a violation of the physical laws of the universe, and we usually think of that as magic. But the important thing to realize is, as we're going through this study, and it's not just this week, but as we get into talking about evolution, every single physical law has to apply. They do apply everywhere, all the time. They must, by definition. So, what are the existing theories for the origin of the universe? Well, the main one right now is the Big Bang, and I had mentioned that a few weeks ago. The idea that the universe started, depending on the numbers they talk about, anywhere from 12 to 15 billion years ago. And it started as this super dense, literally zero dimension point of matter, this infinitely dense point of matter that explosively expanded. That is the mindset, or the basics of the Big Bang. And then gravity, the force of gravity, causes contraction into other areas. After this explosive expansion, gravity causes these contractions that produces all the other things that we see, stars and galaxies and planets and all that other stuff. That's the current sort of mainstream theory of the origin of the universe. The other major existing theory is what we believe, and that's the creation theory. We're focusing on biblical creation because there are other creation theories. There are other creation ideas of the universe coming into being. We're focusing on biblical creation, and that's the Genesis 1 account. All right? The creative and conscious action of an omnipotent and all-powerful being. God. That's the idea of creation. That's the main creation theory. Something that's very, very important to realize is that I don't care which side of it you're on, whether you're on the Big Bang side, whether you're on the creation side, whether you're on the steady state side, that the origin, that the universe has existed, has always existed, will always exist. That's the steady state theory. None of them can ever be proven. Ever, period, end of conversation. Cannot be proven by scientific method. Because the scientific method, the idea of coming up with a hypothesis, well, go back. Define a problem. Well, what's our problem? Where'd the universe come from? Okay, so we've got a problem. We've got a possible solution, a hypothesis. We test that hypothesis by doing one of two things. We either observe the process happening in the universe today, which we can't see because we're not at the time of the creation of the universe, or in a laboratory, we reproduce it, which again we can't do. Because we can't do that, we cannot do any kind of experimental repeatability. We can never prove any origin theory. It's impossible. Unless you can go back in time. Whoops. What did I do? Unless you can go back in time, which we can't do. Really? You're going to do this to me? That's just me. I hit a wrong button. Not layout. That's better. Cool. So we can't repeat the origin of the universe in a laboratory. Can't do it. All right? Cannot be done. And we can't go back in time and watch the origin of the universe. What we have to do is look at what we see in our current observable universe and use that as our way to be able to try to prove our hypothesis. And they are indeed, it is indeed a hypothesis. If you have a body of evidence to support that hypothesis, it eventually becomes a theory. And that's sort of where we're at on either Big Bang or creation. It's a theory. Until you get to the point where you've got really irrefutable evidence, which I believe we have on the creation side, they don't have that on the Big Bang side, it never graduates to the level of being a law. And origins, the law of origin, that doesn't work. We're trying to come up with an explanation, and even using that word theory and scientific method is a little incorrect in talking about origins, because the point of the scientific method is to eventually come up with a law, a mathematical representation of a particular process, whether it's gravity, whether it's motion, whatever it may be. Well, you're not going to have a law of creation. That's a little bit on the silly side. But we can still try to come up with some kind of an explanation for where we came from. So let's sort of walk through our possible explanations. let's talk about the Big Bang Theory. The Big Bang, or I sometimes refer to it as a big bust, it is the most accepted non-God creation theory for the universe today. All right? Most scientists would say that they believe in the Big Bang Theory. And it was developed by a scientist by the name of Georges Lemaitre back in 1933. A astronomer by the name of Edwin Hubble, the Hubble Space Telescope, that guy, it's named after him. He made some observations of the universe, and looking out with telescopes and objects in the universe, he found that no matter which direction in the universe you looked, things were moving away from us. And there's a way that you can find that. There's a way you can figure that out. It's something called redshift. But they looked at the universe, or he looked at the universe, and saw that every direction he looked, things were moving apart. And he didn't have an explanation for that. You sort of look at that and go, wait, if that's the case, Lemaitre took that mindset, taking Hubble's observations from the late 20s, and sort of said, well, what if we run the film backwards? If, as we're moving forward in time, the universe is expanding, well, if we go backwards in time, the universe had to have been contracting, so that you run it backwards and eventually you get to the point of that single point that is the origin point for the universe. It sort of makes sense. I mean, when you look at it from that standpoint, it's a reasonable set of conclusions to draw from the observations that were made. Fred Hoyle, the astronomer, gave it the name the Big Bang, and it was a disparagement. When Lemaitre first presented this idea to the scientific community, the general reaction was, what, are you nuts? Are you kidding me? Yeah, the universe expanded from this explosive expansion, like a really big bang, and the name sort of stuck. A number of years ago, there was a science and science fiction magazine called Omni magazine. And back in the 80s, they put out an article and said, well, for the 50th anniversary, this was back in 1983, for the 50th anniversary of the first presentation of the Big Bang Theory, let's come up with a different name. What if we came up with a different name for the Big Bang Theory? And they put it out to their readers. Nobody came up with anything better. That was sort of the best description for this particular theory for the origin of the universe. Now, the Big Bang Theory, it replaced, and we had talked about this a few weeks ago, it replaced the idea of the steady state universe. The steady state universe is that the universe has always existed, will always exist, basically unchanging. That sort of is sort of a takeoff from Greek and Roman mythology. They really don't have an origin theory per se. It's more that the universe has always been around. Until these observations that were made. It does introduce an interesting implication, though. Because prior to 1933, with this idea of steady state, scientific mindset was that the universe has existed and will always exist, and here it is, period, end of conversation. But science is now accepting the concept that there was a creation, that there was an origin point. That's an interesting and very important distinction to make, because they're actually accepting of the fact that the universe did originate at a beginning point. The interesting question, of course, that we have with this definite start point, the interesting question that we have is, well, what was there before that? That's question number one. What was here before the Big Bang? And that leads into another theory. It's related to the Big Bang, And that is that, so we've got this explosive expansion. The universe is expanding outwards, and there are three possibilities of what could happen. Either number one, the universe continues to expand, and eventually, because that material is expanding outwards, the place where it started has no more stuff anymore, which is what they refer to as the cold death of the universe. The second possibility is that the universe just continues to expand at a constant rate. That's the second. The third is that gravity is just strong enough that this expansion is going to slow down, stop, and then gravity is going to pull it back together again. And it gradually pulls it all back together again until it contracts into a single point and then explosively expands again. So we sort of, those astronomers sort of take the steady state theory and stick it into the Big Bang, that the universe has always existed. It's just going through this cycle of expansion and contraction and expansion and contraction. With each time it happens, it's a new universe with a new set of laws and everything else that comes into existence. All right. You sort of sometimes kind of go, really? They really believe that? We have the mindset, though, of creation by design. The Bible, all right, the Genesis 1 account of the origin of the universe. And the interesting thing is there are a number of scientists that have expressed this mindset of what is referred to as intelligent design. And we had talked about it a little bit, and we're going to look at it a lot more today. These are the ones that are Nobel laureates that have won the Nobel Prize. Fred Hoyle, that astronomer that called it the Big Bang. Carl Sagan, very much an atheist, and yet he still had this mindset of intelligent design, that the universe seems to be perfectly set up for us to exist. That's intelligent design, that something was the designer, something was the instigator of this process and put it together exactly the way it has to be. Stephen Hawking, he had ALS in the wheelchair. Brilliant physicist, astrophysicist. NASA astronomer John O'Keefe. Albert Einstein very famously said, God does not play dice with the universe. Einstein was Jewish. He was not really a creation believer, and yet he believed that there was this interesting order to the way the universe is put together. So the evidence. What evidence is there that the universe was put together in a very particular way, as opposed to the Big Bang Theory? And that's the thing with the Big Bang Theory, and it's the one that always sort of makes me go, If you took a car and put it out there in the parking lot, and you put a 5-pound lump of C4 plastic explosive in it and set it off, and made that car go boom. Mythbusters was one of my all-time favorite TV shows, and they did that with a cement mixer. I love that one. It's gone. Does that car that just blew up in any way, shape, or form come back together again to look like a car? No. But that's sort of the mindset that they have in this idea of the Big Bang Theory, is that you've got this explosive origin to the universe, this very, very, very chaotic origin to the universe. And we talked about that when we were talking about some of the laws in the Bible, some of the scientific truths that are in the Bible. That idea of the second law of thermodynamics, that things always progress in the state of greater and greater and greater disorder. that the universe is aging, the universe is falling apart. And yet, what they want us to believe is that this explosive expansion, this chaotic explosive expansion, then creates the order that we see in the universe today. That doesn't make an awful whole lot of sense. But if we go through and we look at the things that are in the universe, evidence of creation by design, intelligent design, the necessary elements for life, the big one that we need for life, every living thing on this planet, and that's the only place where we have life at this point, every living thing on this planet, the origin element is carbon. Okay? And carbon shouldn't exist. The way carbon is in our bodies should not exist. It requires a very, very specific energy level in order to exist in very large quantities. And yet, that literally everything we look at has carbon in it. That's that whole big deal of global warming with carbon dioxide and everything that's living, organic chemistry. Anything that's organic is something that is or was living. Organic chemistry is built around the chemistry of carbon. That's the way our universe, that's the way our living universe is put together, with this idea of carbon. And yet, carbon as we see it should not exist. The formation process that brings about carbon also brings about other heavy elements that, again, should not exist. We're looking at going from less organized, less complex hydrogen and helium to more complex. And that should not occur. That's not something that should naturally happen, and yet we see it. The mass of the proton, the mass of the electron. Okay, let's go back to science class. Every bit of matter in the universe is made up of atoms, and atoms are made up of three particles: protons, neutrons, and electrons. The nucleus, the center of it, is protons and neutrons. The electrons go around the outside, sort of like planets going around the sun. The ratio of the mass of proton to electron. The proton is 1,836 times heavier than the electron. It's in the nucleus. It's in the center. Less than 1% difference, molecules don't happen. If you don't have molecules, you don't have the long-chain molecules that make up the organic molecules that make up us. All you have out there in the universe are just atoms, individual atoms floating around. All right? The fundamental forces, very closely related to that: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. The strong nuclear force holds the nucleus of the atom together. The weak nuclear force sort of, that's the one that's weird to describe. The weak nuclear force deals with radioactive decay. It also holds the atom together. The big ones that we're talking about, electromagnetism and gravity. All right, positive charge, negative charge, they attract. A positive and a positive repel. If those forces were only slightly different, particularly electromagnetism, if the force of electromagnetism was only very, very, very slightly different, if it was very slightly weaker, chemical bonds don't form. So molecules don't form. If they were very, very, very slightly stronger, molecules form, but they never break. And it's very important in a lot of the processes that go on in the universe that we have molecules where the bonds form and break. The most fundamental one for us is with oxygen. We breathe in air, and air is in, there's oxygen is in the air. It goes into our lungs, goes into our bloodstream, and a chemical called hemoglobin that's in our red blood cells grabs a hold of the oxygen, chemically bonds to it, and becomes something called oxyhemoglobin. That gets carried by the blood out to your cells, and then that bond breaks. So the oxygen breaks away from the hemoglobin and goes into the cell. Carbon dioxide is released from the cell and bonds to the hemoglobin, and it forms something called carboxyhemoglobin. And then that goes back to the lungs, and the bond breaks again, and the carbon dioxide is released back to the lungs, and we breathe it out. And that cycle is what takes oxygen to our cells and takes carbon dioxide as waste from our cells. If that electromagnetic force was very slightly stronger, the hemoglobin grabs the oxygen and never lets it go. If it was very slightly weaker, it would never grab a hold of it in the first place. And then even that balance between the chemical bond of hemoglobin to oxygen and hemoglobin to carbon dioxide, very, very similar strengths. So it's very easy for that process to happen. Very slight differences, and it never happens. We never have those chemical reactions happen, and that's one of the simplest ones. There's far more complex chemical reactions that if those bonds were very slightly different. Proteins. Proteins in our body are these huge long-chain molecules. They form the basis of our living cells, are proteins. The chance for a protein randomly forming a functional protein. You can take elements, I remember as a kid, remember they would sell those home chemistry kits? And it came with, and there were specific experiments you were supposed to do. Who did the specific experiments? No, you just mixed the stuff together and you saw what happened. Well, they were careful not to give you anything like sodium or anything crazy like that. But you can mix things together and get chemical reactions. They may not be useful chemical reactions, but they're going to happen. Proteins are the same way. Proteins are made up of chemicals called amino acids. You can put together amino acids all you want, and you can get this thing that is technically a protein, but it's not anything that's functional. It doesn't work. It doesn't do anything. The chance of randomly forming a protein is 10 to the 40,000th power. That's 10 followed by 40,000 zeros. Anybody feeling lucky to play the lottery tonight? You'll win the lottery a lot quicker than you'll do that, because there's only 10 to the 80th atoms in the entire universe. And this is going to randomly happen? It's impossible by pure chance on the Earth or anywhere in the universe. There's 10 to the 80th atoms and 10 to the 40,000th chance that this is going to happen all by itself. It's that thing of the infinite number of monkeys on an infinite number of typewriters just randomly typing letters. Eventually, they're going to, by pure chance, come up with Hamlet. But what's the chances of that happening? A lot better chance than this happening by many, many, many orders of magnitude. Gravity and electromagnetism in stars. Now we're not talking about in our bodies, in stars. Gravitational pull pulls the star together, that generates heat. The thermonuclear reaction presses outwards. That balance is what makes stars function. If the gravity is too strong, it just collapses. If the electromagnetism is too strong, it explosively expands. Stars never exist. 1 divided by 10 to the 40th. That's 1 divided by 10 followed by 40 zeros. That amount of difference in the gravitational force, if you make the gravitational force that amount stronger, the stars they collapse, they compress, and they never come into existence. Make it that amount less strong, and they explosively expand, and they never form. And we never get stars like the sun coming into existence. That tiny, 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 tiny difference makes all the difference in the existence of stars. They do have an explanation for this, by the way. We'll keep going. the low entropy start of the universe. Entropy is disorder, all right? The universe started with a very low value of entropy, all right? Entropy is disorder, chaos, the potential for order rather than disorder. Wait a minute. And yet the universe started with this explosive expansion? Explosions are really kind of disordered to me. The fact that the Big Bang was an explosive expansion would sort of imply that the universe should be a chaotic start, a disordered start. And yet, the universe has a very low level of disorder, because remember, by the second law of thermodynamics, it tends toward more and more and more and more disorder. So in order for the universe to come into being and to exist, it would have to start very ordered and become less and less and less and less ordered as time goes on. That's what they say, and yet an explosive expansion sort of implies to me that it's going to be a very disordered origin, not a very ordered origin. They've got no explanation for that one. It violates the second law of thermodynamics. I mean, we've all heard of Newton's laws. The laws of thermodynamics, the first, second, and third law of thermodynamics, are even more fundamental than the laws of motion. It violates the second law of thermodynamics. There's no way that this can happen. It's impossible. We're going to stop right here because it's 10:30. I'm going to continue next week. They do have an explanation for this, by the way. They do have an explanation for this. The reason why we observe a universe that seems to be fine-tuned for our existence is because we're here to see it. Huh? If the universe wasn't fine-tuned for us to exist, we wouldn't exist, and therefore we wouldn't be here to be able to look at it and say, wow, doesn't this look like it was fine-tuned for us to exist? Remember that idea, that theory wrapped around the Big Bang? Explosively expand, then contract, expand, contract, expand, contract. This happens over and over and over and over and over and over again, all the way back into infinity. And we just happen to be living in a universe that by random chance, it just so happens that it's put together good enough for us to exist. That's their explanation. That's their explanation. Believe it or not, that's their explanation. Good.
I'm sorry, I have to say something.
Go ahead.
You said just a minute ago that we're trending towards disorder.
Yep.
We started with order, or
Yep.
this is what they believe.
Yes.
We started with
Oh, we are. That's definite.
and we're going towards disorder.
Uh-huh.
Doesn't that completely mess up Darwin?
Yes. Well, that's next week. That's evolution, yeah.
The absolute opposite. I'm sitting here, I'm going, wait a minute.
Oh, yeah. But you can't make that argument to a Darwinian evolutionist because they're biologists and they have no clue about physics. They just look at you like, huh? Literally. Anytime I've had a conversation with somebody, I said, well, how does that square with the second law of thermodynamics? And they said, the second law of what? The second law of thermodynamics, that processes tend toward more disorder naturally. Take that thought. I've got a deck of cards. In order, by suit, in order, ace to king, by suit. All right, I've got it in my hand. Everybody close your eyes. I'm going to take it. I'm going to throw it up in the air. All right, open your eyes. What do you see? The cards all over the place. That's the second law of thermodynamics. Right. But if you open your eyes, and laying here on the floor are 4 piles. Hearts, clubs, diamonds, spades, in order, ace to king. What do you think? One of 2 things. What do you think? Magic or some outside guiding influence had to organize those cards. So I grabbed them all and piled them up before I told you to open your eyes. That's creation by design. God put the universe together the way it is. He put it together in order the way it is. Yeah. Yep. God can violate the second law of thermodynamics because he's the one who made it. And because he exists outside of the universe, all right, so therefore he has the ability to be able to do exactly that. Yes, 100%. Yeah, we'll see that when we get to evolution. Absolutely.
Jim,
Yes.
if you keep extracting and expanding you.
Yep.
It's like a rubber band. It's
Yeah.
gonna break sooner or later.
I guess.
Yeah, I think so.
And where did this, all that thing does is it kicks the can down the road, because what kicked off this process to start with? Where did this blob come from to start with? What's it expanding into? Yeah, it gets weird. It gets weird. And especially then you get to the idea of there's some other mindsets, the what they call the many worlds theory, that literally every decision we make creates a new universe. That and the Marvel Cinematic Universe grabs onto that recently with their new line with the multiverse. That literally every decision you make, the fact that I decide to put this microphone in my left hand instead of my right, generates a new universe. And another one, and another one, and another one, and another one. Yeah, I know. It starts giving me a headache. It does. It does. Again, none of which we can prove, because there's no way you can jump to that other universe. That also, by the way, is the explanation why we can never go back in time. Because the second law always says that things have to go in the direction of more and more and more disorder. Well, if we went back in time, we're going back to a time when there is more order. You can't do that. You can't do that. It's violating the second law. We're doing time travel right now. We're moving forward in time at the rate of 1 second per second. Thing is, you can't go backwards. You can't go forwards faster. You can't go forward slower. It is what it is. And time comes about because of the second law of thermodynamics. It's all part of it. So we're going to continue with this next week. I'm about 2/3 of the way through the creation by design, and then we're going to get started into starting to talk about evolution. That section on evolution probably is going to take me 3 weeks. We'll see how that goes. Thank you very much, everybody, for coming out. Hold on. Keep your questions. Ask them as we're going through. I welcome the questions. We are going to have the very final week of this is sort of going to be an open forum questions. If there's anything that we came across that you had a question about, something that you do your own looking at things, which I really encourage, please hold on to those, bring them along, and we're going to have that real sort of open forum the very last week. All right? So how about we close in prayer, and we'll get ready for service. Lord, we thank you so much for this day. We thank you for bringing us safely back here to church, back to your house, Lord. I thank you for the time that we've had together, for helping my voice to hold together, and for the open and attentive hearts that we've had here today. I pray that you would help us to be able to absorb this, to be able to understand it, and to have it be able to really strengthen our faith. That's really where it comes down to, Lord, that it strengthens our faith in where we came from and the fact that you exist, that you control everything, that you control all that we see, all that we do. You have everything in your hands, Lord. All these things we ask in your Son's name. Amen.